This is my reassessment for angular momentum. And you see I drew my two diagrams, but we're going to look at this one first with a young man on a spinning stool with his arms out. And his spinning rate right now is 15 rads, so I wrote down top. And the inertia and potential is 3.4, and that's with his hands out, or side to side. Then I drew another one with his hands in his pocket, and his inertia is 2.3 kilograms per meter to the second power. And we don't know his how many spins he does. So I came over here and I wrote down what we knew. F net equals 0. So and that equals the initial time thing over time. Then I did the torque net equals 0, and that equals the length versus over time. And we see that L1 and L2 are equal. So the inertia with the omega inertia, the omega has to equal the inertia 2 with the omega 2. Alright, so then I did some algebra to find out the omega 2, and I have inertia 1 and omega 1 on top of inertia 2, and that's when we get 117.3 rads per second. So we're going to use this down here later on. And you see I have omega equals the kinetic energy rods, and then omega equals kinetic energy rods plus the earth and potential, that's E earth. And then kinetic energy rods equals kinetic energy rods 2 minus the F rods. So you have to do half, so that's when you get 1/2 inertia 2 omega 2 to the second power minus 1/2 inertia 1 times omega 1 to the second power. So then I also plug in the formulas, and then you see the one I got up here. I just use this to get 2 out because that's what it equals. Omega 2 equals inertia 1 over omega 1 over inertia 2. That's why I plugged that in, so you can just plug in that answer right here. And then you get the minus 1/2 inertia 1 over omega 1 to the second power. And that's when I get 1/2 inertia 1 times omega 2 open parentheses inertia 1 times omega 1 over inertia 2, then you minus it by the omega 1. And I got 70.3125. That's how much work that he did on himself. That's my reassessment.